started the strip till, I think it was just to try and reduce our full tillage to a more conservation tillage. So we actually started first using it on our forage corn and soybeans, and a little bit on our processing vegetables. And it was to, in our forage corn specifically, instead of having 2 full tillages, we were trying to do one after manure and then use the strip till for preparing the seed bed for the corn. Then it developed into, it works really well after the full 1 tillage. Can we do it without a full tillage before there? Can we even reduce our tillage further? And then it was, can we put product through our strip till and for these crops, and how does that help these crops, and could we ban the crops? We saw when you see those crops at a 4-inch ban and they were able to get those fertilizers or whatever you're putting on, and they have a response, we say, okay, can we ban it 4 and 8 and get even more finite? And then we really, when we started to get into organics, it became an incredibly useful tool for putting on the organic products that are very expensive and reducing and keeping our costs lower for per acre by placing those products. And then it also worked into when we did crops, can we reduce our weed pressure in our conventional and our organic crops? Can we go into a living cover and still have a good germ on crops and have really good weed control with good soil health? So it evolved from becoming a alternative tillage tool to a soil health tool.
And using the strip till has really taught us a lot about our crops and our fields in general. Not every time was a success. There was times that we didn't like the results, and we didn't have a lot of reference point, being that there aren't a lot of people in the Central Sands area of Wisconsin that use tillage. So we've had to look around the nation. We've had to use Strip Till magazine as well as conferences to talk about other people and learn about what their best practices were, and try and figure out how to adapt that to our different soils and our crops. Some things that we tried to do that didn't work is we tried to go into some really heavy cover crops, or in a living cover, and use a strip till. And we found out that just in that specific year, the living cover, we probably planted a little bit too late, still overtook the rows. But we found that if we did a strip till event twice instead of once, or different fertility practices, that we could overcome that. And it's using that and adaptive practices that has really allowed us to figure out what has responded in our soil and how the strip till can be incorporated into that to get the best possible outcomes. An example of another failure would be, we're sitting in a pumpkin field now with rye that we strip tilled that was up to our shoulders, and we've always done it 2 or 3 times in order to get through the field. Something early when you're a couple inches tall, something maybe when it's just starting to go to boot, and then right after we crimp. So we were hoping that we could get down to 2 times to reduce our tillage events and reduce the soil structure that we're breaking up actually within the strip till zone. We found out the year that we tried that we crimped it, and we just had so much biomass that our strip till, we were going along at 3 miles an hour and stopping every 50 feet to take rye off the coulters and the different depth gauges, and it was just a mess.
Well, the best part is we tried it again the next year because we didn't learn our lesson well enough. So we said, maybe our timing was off, and it was just the same thing. So that's always fun, to try and figure out what you can try and push the boundaries and get away with. And then when you get it right and find that perfect edge of what you have to do and still get a nice looking crop out of it, it really is rewarding to finally find that, and it makes it all worth it. Something we also use is for looking at the crop, is not just going out and saying, well, this looks nice. We use harvest data, harvest points. We used harvest monitors, and we can actually pinpoint the areas we had those experiments and look at the actual yield or the return on the ROI on that. So that was really useful for us to know, not just qualitatively, but quantitatively on what was working or not.
Can you expand a little bit on that, Megan? And you mentioned, ROI is a huge 3 letters when you put them together, and obviously that's something that particularly nowadays everybody's very interested in tracking. What have you guys been able to find, really kind of digging into some of that, the data side of what you're trying to track?
Well, there are a couple crops that we always use a control, we use a new practice, and we use kind of a standard practice that we've done. And we've looked at different kind of yields along with costs that we've put into trials. And there are times that in soybeans that we actually pick up a bushel. However, our cost is $12. And unless we have $14, $16 soybeans, which we haven't seen for a little while, even though we're getting increased yields, it's not worth doing that new practice. However, there's other times that we're either decreasing cost, decreasing inputs, or increasing yield without increasing cost or inputs, that our ROI is always positive there. Now, we have to make sure that our sample size is big enough to make it relevant, excluding headlands, doing enough replications to make sure that we're actually measuring what we're trying to measure. But utilizing precision technology and precision agriculture, we've been able to figure out at a micro level of what each practices has done over multiple years and multiple fields and replications to figure out that our ROI is positive and put a dollar to the different practices we're doing, whether it's $3 an acre or 25.
Yeah, and something what Eric kind of touched on was the size. When you're using harvest monitor data, it can't just be 2 rows or even a single pass. It needs to be at least 3 passes of a combine head, not just your planter head, but your combine head, to be able to get the right data size when you're in a GIS software. We use the SMS software on the farm, that you can and get a good data set. So, and it can't be on the headlands. We try and avoid the corners, somewhere in the middle of the field where we know, okay, we're gonna get some good data from this. And then through the season, we're getting some of the qualitative. We're digging up and looking at roots, or going and making stand counts, or various techniques to back up any sort of harvest data we'll get. Because sometimes the monitors fail, so we always try and have that backup.
And you have to be impartial to the results. In fact, there's times that I will put a trial out on the farm and I won't tell Megan about it. Now, she doesn't even know where it is. And if she can find the difference without me telling her that there's a trial out there, then we're not trying to force results. Because there's so many times that I've seen farmers, or even ourselves, I've caught ourselves thinking, I want this to work. So we treat it differently throughout the season. And that isn't a good trial. That's forcing a result that isn't true. So blind tests are just as important.
All right, so I got to ask a follow-up question, and I need an example on when you've done that, Eric, to Megan, and if she's found it or not, if she's been able to figure it out.
Following up in some of those trials, it would be flipping. I've done trials where I flip in-furrow fertilizers on and off, or banding in the zones. It's hard to do something that you leave a physical evidence behind, or sometimes I just forgot to use a product, forgot to turn on my pump, and it ends up being a trial.
Yeah, we had corn that we put a pop-up in, just a conventional forage corn. And there was an issue with getting the product in, and timing for planting was, squashed a little bit. So they went ahead and did, 15, 20 acres without that product in the planter. And I'm going through the harvest stat at the end of the season. I didn't know this. And I called Eric and said, Eric, I'm not getting, it looks like it's the same harvester, but is there something wrong? Was it not calibrated? And he went, oh.
To a row.
Yeah, it was line in the middle of the field. He goes, no, we didn't put pop-up there. And I was like, this is like a 6 bushel, like a 6 bushel or a 12 bushel loss or something. It was about a ton and a half. So when you're looking
at ROI, it was about $28 an acre less in yield, but only $3 an acre less in cost. So $22 an acre was our ROI by using a product. And it was a micro, so it wasn't very expensive. It was, a little bit of popper, something that was there, but it was a fully manured field, so we should have had the availability. According to several publications, we had the availability and we shouldn't need this product. However, we did see results very strongly. So that is why it is good to check your best practices and make sure they're still relevant. Because if you've changed practices from something small, from what you did 10 years ago, maybe your current best practice also has changed in its core and base assumptions.
It's also important to have everyone in your farm understand what you're doing. So we did some non-vernalized rye, meaning rye that's planted late into soybeans, so it's not going to go to reproductive stages. So we spread that, we broadcast it into our organic soybeans as a weed control. And we did this over several years to get the results. And what we find is that we will have equal or lesser yields than our traditionally cultivated soybeans. And it could be 5 to 7 bushels less. However, your costs of avoiding 5 to 7 cultivations, plus the soil disturbance and everything going on in your soil health that you can't, measure, it turned out that even if you lose those bushels, it was better. So we had to go through and we explained to all of the employees, all the managers, yes, we're getting lower yields, but our return on investment by using this is actually a lot higher, and not just in cost, but in man hours.
Well, there is one specific field for that trial as well. So we are fully irrigated in organics. However, there was a section in that organic field that was dry land. So you would think that having a living cover crop would compete for a water moisture. However, we saw a negative correlation in the irrigated soils, but in non-irrigated, we actually saw a positive correlation because it was a very dry year.
It was very dry.
And we don't hold on to water well at all. But in the dry land, where we had a living cover crop along with the soybeans, we actually increased our yield and decreased our costs. Those are the wins that we strive for. So in that case, we actually use the rye as a mitigation strategy, even if it doesn't return. In this case, it did, but even if it didn't return on dry years, if you can protect your yield rather than just trying to increase or decrease costs or increase yields, protecting what you already have sometimes is worth it.
Yeah, it's a better choice.